TV. I'm here today with Professor Simon Clarke from Oxford University. So welcome and thanks for being here today.
Thank you for inviting me. Very nice.
So let's start talking a little bit about the conference. So it's really bringing together scientists from all over the world. So can you name some of the highlights that you're looking for or that you've seen so far at the conference?
I think, it's a very diverse conference. I'm here contributing to something that's really solid-state chemistry, the sort of underpinning topic for materials science. We had a nice talk yesterday from Professor Hosono from Tokyo Institute of Technology, who's made great advances in ammonia catalysis, discovering new compounds such as iron-based superconductors. So he's one of our sort of trailblazers in taking original solid-state synthesis and developing useful materials from that. So I think that's probably one of the main emphases out of this sort of Materials Research Society concept, that it represents people from the solid-state chemistry end through to sort of materials applications and so on, and trying to bring those people together. I think it's quite a difficult thing to do because people sometimes tend to crystallize into their own symposia, but having everybody together should encourage people to sort of explore where they can contribute to material science problems.
You just mentioned the interdisciplinary approach that we have here. So how important is this to you personally, also for your research?
I think, so I suppose I think the key for interdisciplinarity is to develop collaborations. So because everybody has their own area of expertise, I guess for me it's sort of synthesis and structural characterization of new compounds. But then we have to collaborate with other people who have expertise in characterization. I think it's very difficult these days for people to work across the whole of sort of materials science. So the key is to develop these collaborations, which then leads to a sort of interdisciplinary team that pushes forward on solving problems like making new battery materials and making new photovoltaic materials and so on.
So can you tell us a bit more what role EMRS plays for you in your research and why you decided to come here?
So I was invited to contribute to a symposium on mixed anion compounds. So these are compounds that contain oxide and, for example, sulfide or hydride ions. And so this is a rather new area of solid-state chemistry. We heard a lot of talks yesterday on oxyhydride materials, compounds that contain oxide and hydride anions, and how they might be useful in various ways. But it's very exploratory. But I think it's good that that sort of subject is incorporated into the sort of MRS, and it always has been incorporated into the MRS program, so that you can people can see what new compounds are available and how they might then use related examples to generate new materials in their area.
So are there any particular trends or developments for materials research that you think are mentioned here at EMRS?
Yeah, so I think there's a lot of interest in battery materials. There's a big push towards electric vehicles at the moment. That's a big challenge, trying to increase the number of electric vehicles in a sustainable way, using sustainable battery materials and so on. So that's a big challenge, but it's well represented here, and it's an example where of an area where new compounds can feed into the development of new materials. Other big areas like photovoltaics, trying to harness the power of the sun to make electricity is a big challenge as well. Looking at water splitting to make hydrogen as a fuel is a sort of related challenge to that. All these things require new compounds, detailed characterization using state-of-the-art techniques, and then if you actually want to make a device, you've got to think about processing and microstructure and so on, and perhaps making composite materials. So that's where I think in this conference we've got sort of representation at all those levels. But as I said earlier, it's quite difficult to cut across all those levels as an individual. We tend to focus on our own discipline, probably necessarily. But hopefully the communication between groups enables research to progress, and people become aware of what the potential new compounds are that could be used.
And talking a bit more about your symposium, so how does it fit into this?
So it's very much at the exploratory end of things. So we're talking about new compounds, new crystal structures, how they're synthesized, what are the challenges in synthesis, what their physical properties are, and then a little bit in terms of trying to look at their functional properties, but that would need to be developed for a proper device application. So that's where we would sort of pass up to the sort of the genuine material scientists.
So is it more fundamental research, or are there also like applications that?
I mean, we always. I mean, I think as solid state chemists who are doing exploratory synthesis, and I certainly put myself in that category, and I think it's very important to explore new compounds for new applications, but we of course have applications in mind in the future. So we think about how could we design a new battery material, and we might take input from obviously the literature that's been accumulated over the years, and then increasingly we can use computational expertise to quite rapidly screen potential new compounds. We're quite good at predicting stable materials using computation, and then we can sometimes identify targets computationally. Of course, we then have to make them, and that may present its own challenges. But I think it's very very important to bring through these fundamental materials. I guess we're trying ultimately to make smart materials. We end up making a lot of not very smart materials, but they tell us something at least.
Yeah. Okay.
Yeah.
So you mentioned challenges. So what are those challenges? Can you give more detail, or what are the chances that you see in your field of research?
Well, I think they're quite diverse. I mean, the area of mixed anions that I'm focusing on, it's largely untapped, but there are all sorts of possibilities to make new magnetic materials, new optical materials, potentially new battery materials. And the challenges are always, from my perspective, are to make compounds and characterize them accurately and decisively, and then put them out there for the rest of the community to potentially develop.
So you mentioned magnetic materials and also battery materials, and we at Fraunhofer IWKS are also looking into recycling those materials and regaining the scarce elements, for example cobalt.
Yes.
So how do you think can your area of research contribute to like recycling or making materials more sustainable or technologies?
Yeah, so I think if you're thinking of scaling up battery applications for vehicles, we've probably got to move beyond cobalt because it's a relatively scarce element. It's not mined in a very sustainable or friendly way in the Democratic Republic of Congo. So I think we need to look for more benign elements like iron, for example, as the active electrode materials. So I think that's the sort of thing that's starting now. We've got great materials that work with cobalt. Increasingly, new battery materials are being discovered that move beyond cobalt, but I think we need to move to compounds that are much more abundant in nature, so that we can move to scale. I think that's a big challenge with any of these new energy technologies that sometimes doesn't get thought about. It's doing these things at scale is really difficult. Lots of big batteries, lots of photovoltaic plants, and scaling that up to the large scale for energy storage or energy generation by water splitting or photovoltaic generation is a real challenge.
And what do you think? Because we are also working on design for recycling. So one of the approaches that we do is, or the ideas that we have, is to make markers at like scarce elements, so we can track them through their technological life.
Okay.
Do you think this is the future, or is there any development?
I think that's very important. It's not my area of expertise, but I think an element like cobalt is one where you really do have to focus on recycling, and even, probably then, my guess is it's not going to be, as I said earlier, that what you would use for the huge scale applications. But all our mobile phone batteries that get discarded, I think we need to reclaim all the scarce elements.
Or substitute with something.
Or substitute it with something else.
Okay.
Yeah. But I think that there needs to be a focus on, as well as making new materials and new compounds, on recycling. And there's a lot of work in that area. I know that in the UK there are efforts to recycle rare metals like platinum by gathering dust from the side of the road. The little bits that come off catalytic converters are actually richer in platinum than the ores that you normally dig out of the ground. So there are, I think, imaginative approaches to recycling and sustainability are really important. Yeah.
Well, that's a nice ending. So thank you very much for being here, and have a good conference.
Okay, thank you folks. Thank you very much.